Okay, so let's get into types of computing. We're still dealing with basic concepts of computing. And this is the last section for that chapter, so let's get stuck right in. So let's just talk size and processing power real quick. So some computers are more powerful than others, okay? And what do we mean by powerful? Thinking back to what we were talking about a couple of lessons ago. So powerful implies that we can retrieve and process larger amounts of data in a faster amount of time. And remember, a program is just a set of instructions that's executed by the computer in a specific order. So the more powerful our computer, the faster this process of retrieving instructions, processing them, and then doing whatever, executing whatever that instruction asked us to do. So the more instructions that we can process in any given amount of time, the faster our computer is, and therefore the more powerful our computer is. So if you think in terms of a gaming computer, you want a really powerful computer so that you can process all of the instructions that are necessary to be able to run a game really smoothly. And it's in our best interest to have as powerful a computer as we can afford, for any number of reasons, but why? What could you want to process? Well, I just mentioned video games, but what about video editing? That's something that takes quite a lot of power. What about, some kind of graphic design? If you want to get into really, really deep level Photoshop stuff, that requires a lot of processing power. There's a lot that your computer can do, and it's really limited to what you can imagine your computer, you need your computer to do. So what makes a computer powerful? So powerful in computer terms is generally a combination of the speed and performance of the processor or the CPU, the size of memory or random access memory, as we know it, RAM, the short-term high-speed storage that we were talking about. And then the third thing is the amount of storage. So the long-term storage measured in gigabytes or terabytes, so so basically how fast can we process things? How much can we store in the short-term memory? And then how much can we store in the long-term memory? And these three things generally determine the overall power of a computer. So if two computers have a similar processor and a similar memory, if they both have, say, an 8-core processor and they both have 16 gigs of memory, the computer that has the larger hard drive is going to obviously determine it's going to determine which of the two is the more powerful computer. So a general rule of thumb in computing is that as the physical size of the computer increases, so should its processing power. And why is this? Well, if you think about it for a little bit, and I encourage you to maybe think about it, and pause the video and think about it. But for me, the technology associated with what goes into a cell phone, it's so small and so powerful at this point in time. And if you took that same technology and you tried, you said to yourself, okay, you can use that exact same technology, but you have significantly more space to build it in. If, let's say, you had an entire desktop computer to build the technology of a cell phone into, obviously you'd have a lot more capacity because of the more physical space to make it more powerful. So that's why we say as the processing power increases, so does the computers, or as the size of the computer increases, so should its maximum capacity for processing power. So the best desktop computer that you get will blow, the best smartphone that you can get out of the wood, and that will stay pretty relative. So just because there's more space in a computer for components, it doesn't mean it's actually more powerful. Like some smartphones these days are actually more powerful than some desktop computers, and you'll see in class we'll do an activity 1, where we take a look at this and we look at all of the different components all of the different computers in the class that we have, and we compare them against one another, comparing against their processor, their memory, and their size of storage. And we can see that some of the iPhones, I think the iPhone 7 beats some of the computers in the lab, which is pretty impressive. And it's worth noting, so as I'm saying, modern smartphones do outperform some desktop computers. It comes down to the individual device's specs though, the RAM, the storage, the CPU, it all comes down to these three things. You can think in terms of the device's capacity for the best possible hardware. So here's the diagram I'm going to go with. So as you can see here, we have going from the bottom up, so from the smallest to the largest, we go smartphones, netbooks, consumer tablets, laptops, notebooks, tablet PCs, then desktops, then servers. And let's just talk briefly about each of these. So we'll start with the smallest. We'll talk about smartphones. So these computing devices, quite small, not as powerful as some of the more powerful computers, but still pretty powerful little devices. Some of the new iPhones, it's incredible what kind of specs you can actually get into those things. Well, I'm sure for many of you, it's just like, well, this is what it is. But for me, coming from when cell phones were what cell phones were 10 years ago, before we had what we know as smartphones in the mainstream as we know them, before Apple, I guess this is after Apple brought out the iPhone, but before, they completely revolutionized the smartphone industry. These things can be quite powerful. But not as powerful as what you can get with some netbooks and consumer tablets. So same way you can get a really nice iPhone, you can get a better tablet. So consumer tablets are not to be confused with drawing tablets, and especially not to be confused with tablet PCs. We'll talk about those just now. Consumer tablets are mobile devices and therefore generally use some kind of mobile operating system. And then a netbook, I'm sure many of you have netbooks. A netbook is like a Chromebook. It's basically it looks like a laptop that went into the washing machine and got shrunk down. They're generally speaking not as powerful as laptops. You do get some pretty powerful ones, but they're not as powerful as laptops because they're not designed to be as powerful as laptops. They're kind of just designed to be, Chrome machines. They're meant to be used mainly as a web browser device, and that's kind of it. You're not meant to do other things on them besides that. And basic word processing things like maybe like the Microsoft Office. You wouldn't edit videos on a netbook. So moving up then one level, we get to hang on, no, I'm going the wrong way, sorry. There we go. So moving up one level, we now get to laptops, notebooks, and tablet PCs. So what's the difference between a laptop and a notebook? Any ideas? Well, trick question. There is no difference between a laptop and a notebook. It's just laptop doesn't sound as elegant as notebook. And if you're going to be marketing your brand new notebook to the masses, you want to make sure that it sounds nice and clean and classy. And a good way to do that is to change the name and make it sound fancier than it is. But it's a laptop. It's a laptop. We all know what a laptop is. It's a portable computing device that's got an inbuilt screen, keyboard, mouse, and device itself. And then tablet PCs. Now, we differentiate tablet PCs from consumer tablets in the sense that a tablet PC is actually a computer that's running a proper operating system. So the Windows Surface is a great example of this. It's a very strong tablet, or very powerful tablets. That's you can use with a stylus, you can draw on, and they're used a lot in art, and creators tend to use these tablets a lot. So moving on, we then get to desktop computers. So this is what we know of as a computer, and what I refer to a lot when I'm talking about computers in class, just because they're one of the most common forms of computers. Is the desktop computer. Everything that I talk about in class can be applied to every other type of computing device, but desktops are really what I consider to be the main kind of computing device. And there's really not much more to say about them. We'll talk about them in a lot more detail in the coming weeks, but basically, these desktop computers, they have a mouse, a keyboard, a monitor, and then one of these towers, as we call them, or a computer case that has all of the components built into it. And of course, you get some really nice ones, and you can go really cheap with it, you can go really expensive with it, and of course, what you pay for is, generally speaking, what you're going to get in a relative sense. And then lastly, we get to these big beast computers, the biggest, most powerful computers, which are called servers. So servers we'll talk about more in the networking chapter, but basically what a server is a super powerful computer that is responsible for managing all of the processing that happens in a network. So a lot of the time when you're doing something online and you're using a server, just all that means is that your computer doesn't have to process as many tasks because the server is processing a huge amount of tasks for you. So if you're doing something using, say, Google Meet, for example, if we're on Google Meet, then what's happening somewhere is everything that's happening with Google Meet isn't being processed by my computer. My computer is just processing what it's receiving and displaying. All of the actual processing of the Google Meet is happening on a server somewhere. you know, where we have to pay to be able to use it. The school, I think, no, actually the school doesn't pay to use Google Meet, but, you know, just generally, you know, there's a server somewhere, or I guess we're paying in our data really when it comes to Google. And it's the same with, you know, Google Drive. Whenever you save something to Google Drive, or whenever you create a new Google Doc, you're actually creating it on one of these computers. This computer is actually what's processing it. Your computer at home is just processing what has to be displayed of what you're doing on the server. So that service, we'll talk about them in more detail later on. So now let's just talk, why do we even use computers? So computers are fast and accurate. They're good at repetitive tasks, you know, it's counting, arithmetic, you know, checking states, things like that. They don't get tired. They don't make demands. They enable faster communication in terms of networks and the internet. They're excellent record keepers in terms of storage and databases. And they're also multi-purpose, allowing us for many ways to analyze and process data. You know, the whole input, process, output thing. If it's a system, it can be computerized. But then some things to consider, I wouldn't really call these disadvantages, but some things to consider when it comes to the downside of computing is that computers are only as good as the person that's using them. Computers are limited in terms of physical abilities. You know, like a computer actually requires robotic arms to manipulate the physical. It needs some kind of input-output peripheral to actually be able to do things. And then computers can also be really expensive. You know, you do get some cheap ones and you can buy refurbished computers, but if you're going to buy a brand new computer and it's going to be a modern, powerful computer, it's going to be really expensive. And also computers are not yet capable of critical thought, but we are getting there with something called machine learning, and I'm not going to waste more time talking about it now, but it's really interesting. Our computers are actually learning how to think and how to learn using algorithms and using what is effectively linear algebra to train computers to think based on what they've seen of some large data set. It's called machine learning, and it's really interesting. I really recommend checking it out. Then computers also need to be fixed by trained, skilled professionals. You know, it's not just something an average Joe can just, you know, open up. It's you really need to be a trained, skilled professional to fix a computer. They also might need specially developed and expensive software to perform desired functions. You know, like if you want to do creative work, you need the Adobe Suite, and that's expensive. And then computers quickly become outdated as well. So if you buy a brand new, top-of-the-line, expensive computer, it's going to be the most powerful computer or the best in line computer for maybe 2 or 3 days before something better comes along that makes your computer obsolete. And that's it. We're done with module 2.1. We'll come back to ICTs at a later point. So if you're in your textbook and you see the ICT section, don't worry. We actually come back to that in chapter 4. Sorry, not in chapter 4, in term 4. So just sit tight on that for now. If you want to go ahead now, you can go and make all of your notes. Of course, you can be making your notes as you go with every lesson, but you can also refer back to the textbook if you need to for any additional help. So there are now 4 small quizzes for you to complete over the next couple of weeks. Okay, you have quiz 1, which is on what is a computer, Q2 on the expanded model, Q3 on basic concepts of software, and then Q4 on types of computers. Now, the thing with these quizzes is that these quizzes require you to fill in short answers to a few simple questions that relate to each section of the content. The links to the Google Forms can be found in the Google Classroom alongside each video. So thanks for that and take care. Oh no, I'm not done. These quizzes are for marks and should be completed as you revise the content. Remember, study notes are key in IT, and I will be following up with everyone individually to check that you're making some form of quality notes in preparation for your upcoming exams and assessments. And class activity 1 is now going to follow, and that's it.